welcome to NFC Development for BlackBerry 10, a whirlwind tour. Just before I start, can I get a sort of straw poll as to who in the audience believes they sort of know something about NFC at all, even the most small amount of NFC?
They're all
Okay.
experts, Jonathan, no.
Right. Thank you. Well, my name is John Murray. I work in the developer relations team in the UK. I've been around in development for a long time, but currently I'm specializing in NFC, and along with my colleague and co-presenter, Martin.
Yeah, hi, I'm Martin Woolley. Much like John, I work in the developer relations team of BlackBerry as opposed to RIM, and I'm based in the UK. I measure my involvement in the world of software development, regrettably, in decades. I don't even like saying it. But a couple of years ago, I like to say NFC discovered me, and all of a sudden I became more of a specialist, and I spend most of my time as a member of the team working with our partners, carriers, and people like that who are developing applications which exploit the power and flexibility of NFC.
Okay. I think one of the things that if we normally do sessions like this, as we've done in the past, we would normally do a deep dive type session where we would look at one or two particular APIs and take a deep dive on it. We've got two sessions this time in Amsterdam, so this one we're using as a sort of session where we're looking at the breadth of what you can do with NFC rather than looking at the depth. The next session, which I believe is on after this, will be talking a little bit more depth about some of the APIs. So, let's move on. This is what we're going to be talking about, basically. Because it's a sort of introduction session as well, we'll be providing a little bit of a background to NFC, what it is, what you can basically do with it. And then taking a look at probably 5 of the most common use cases that you're going to come across if you start thinking about integrating NFC into your application. We're going to look at tags, we're going to look at peer-to-peer, card emulation and virtual card emulation, and then also one of the things there are reading contactless cards. These are probably the 5 most common use cases that you will find. So let's move on. So near-field communication, what actually is it? Well, the near-field sort of gives it away. It's a very short-range technology, typically 2 to 4 centimeters in distance, which means that when you start to use it, you're effectively got to bring the devices that implement NFC close together to use. So it's sort of technology where you touch things to make things happen. You bring things close, use NFC to trigger events or transfer data between devices that are NFC capable. So touch and the ability to have sort of interactive experiences in terms of being able to bring devices or tags together to do things. So the other important thing about NFC is that it's governed by standards. And standards are very important in this, in that you develop applications to these set of standards that have been implemented on BlackBerry 10, and it means interworking between different vendors' devices is very much easier. Other platforms like Android, or I think even Windows platform, have NFC support, and therefore, if we adopt the standards that have been established here, interworking and communication between those is quite capable of being done. So it's just not radio. It's not purely radio. It's a little bit more than that. It's about the tactile sense of touching things and how you integrate your application with these sort of use cases. So where are you going to find NFC? In a number of places. All BlackBerry 10 mobile phones have them. All BlackBerry devices have them. Most BlackBerry devices. There's a 9900, a Dev Alpha over there. A lot of devices from other vendors have them as well. So it's something that's appearing in a lot more mobile phones more as time goes on. It's not just mobile phones, though. It's other devices, other NFC devices like tags, for example. There are some typical tags, and we'll say a little bit more about that later, but typically they're sort of devices, things like wrist straps, key fobs, or whatever. Other places the NFC sort of appears is to help configure things like a media server there at the bottom, the little black device. Use NFC to configure that and set up the connectivity with Bluetooth. And of course, probably the most common use case that you've heard of with NFC is payments, where you use NFC to make payments using credit cards or debit cards, and that's exemplified there in the particular image at the top. So there's a whole series of use cases there, and we're going to look at NFC tags.
Thank you, John. Okay, so we're talking about 5 common use cases for NFC. We're starting with NFC tags. So I guess the first question we should seek to answer is, what is an NFC tag? I'm going to press this button. There we go. So I have some bullet points I'll walk you through in a moment, but first of all, I thought I'd just show you some tags in case you haven't actually seen any in the flesh, or plastic, or card, because they come in all sorts of shapes and sizes and have all sorts of different characteristics. If I switch to the Elmo thing here, I've got one which is like a plastic card, a bit like a credit card, same kind of size. This one here is flexible, and it has a self-adhesive backing to it, so I can stick it on all sorts of different surfaces. John was saying earlier, by the way, that NFC is popping up in all sorts of places. There are lots of announcements from the Consumer Electronics Show this year that included NFC capabilities and all sorts of unlikely devices. And I think LG have released a range of vacuum cleaners that have NFC, and I have no idea what you would do with that. So I'm intrigued to find out. But back to tags. Here's another one. So again, different shape, kind of flexible, and you can actually see the circuit through it, which I'll come back to in a moment. So you find them embedded in wristbands and key fobs and all sorts of stuff. And that's what a tag might look like. Now, before we talk about the bullet points back on screen, I'm going to show you how I might interact with a tag. And the essence of almost everything to do with NFC is it's about touching, interacting with physical things to accomplish an outcome of some sort. And with NFC tags, what we can do is we can trigger actions. And those actions are taken by applications that you write. So, start with something really simple. On here, I just have some text. Nothing too complicated. If I bring my device into proximity with the tag, a suitable application according to the content found on the tag is launched, and it just shows me that there's a message on there that actually says, "Hello, BlackBerry 10 developers." It's like a friendly greeting from my device to you. So there you go. So NFC is friendly as well. So let's go back to the slides and just talk about some of the kind of bullet point characteristics of NFC tags. Number one, they're memory cards. They store data. And when we talk about the data on NFC tags, we talk about messages, and messages contain records. There's like a hierarchical containment structure, if you like. And that structure is defined by a standard. There's a format called NDEF, I think I mentioned on the next slide. Where NFC comes into it is that these memory cards that have data on them also have a contactless interface. So as you saw when I bring my smartphone into proximity with the tag, the data kind of jumps across the contactless interface to the device, and the device gives that data to an appropriate application. And we'll talk about how we decide which application is the one that should get that data in a moment. Once it's given to an application, you can do anything. And again, that's where you guys come in, because you've then got access to all the APIs that the platform offers, and you can respond to and use that data in any creative way you like. So tags can be all around the home, they can be in cars, they can be in the office, and they can help make convenient and easier the triggering of actions and so on. So, tags themselves don't do much on their own. They work in conjunction with another device. In this case, that was my smartphone, and we term that the reader. So the reader comes into proximity with the tag, and the two behave as I described. And again, critically, the final link in the chain is the application which consumes the data and responds to it in some useful or entertaining way, whatever your great idea for NFC tags might be. Now, John mentioned standards, and most of the technologies underpinning NFC, and there are several, have standards that are governed by a body called the NFC Forum. So they have a website, and you can download specifications from there. And this is true of NFC tags. And the NFC Forum have defined there to be 4 different types of tag, and they gave them these great names that are impossible to forget. There's Type 1, Type 2, you know where this is going, yeah, Type 3, and of course Type 4. So, not too hard to remember those particular names for standard types. So I mentioned the message format. So we have messages that encapsulate records, and this data format is called NDEF. That's the NFC Data Exchange Format. So any data on a tag is in that format, and it's actually very versatile. When the NFC Forum kind of worked on this area, they anticipated a number of what they thought would be very common use cases. So, for example, a tag with a URL. It's likely there's an application on any device that can handle a URL, like a browser. There's probably going to be an application that can display text. So simple things like that they anticipated being used quite commonly and being supported by standard applications that devices tend to have. So they defined some special predefined well-known record types to handle those types of cases. But beyond that, you can put MIME types on NFC tags. So you can put a V card on there with its MIME type, or an image, or a music file if the tag's large enough. And also you can create your own types. So I've talked here about custom types and in quotes external. External is the official term they use in the specs. But a custom NDEF type is one that you have invented. So you can invent your own types and bind those tightly to your application, because then only your application will be considered capable of consuming and processing that data. Last thing to say on tags here is that they do have quite varying capacities, which range from an incredible 64 bytes, minus some header system information, leaving you not too much left, up to around 8K. Okay, so if you're looking to buy tags, make sure you consider capacity and conformance with the standards, because some of the tags out there do not comply with the standards and will not work with the BlackBerry smartphone, because standards matter and we're not supporting the non-standard stuff. Okay. Let's talk about how they work, kind of briefly, I guess. But these bits of paper and card and so on have circuits inside them. I'm going to try and show you what one looks like right now, up here on the Elmo visualizer device, which is ignoring my button depressions. Let's try again. There we go. So here's a tag, and in fact you can more or less see it anyway. Can you see that? You can probably see the tracks there just about. There you go. So that's circuitry, and most of that's an antenna. But there's a small integrated circuit in there as well. So that's where our data is stored. But it's worth also considering, where on earth does the power come from to power the circuit? Because there's no battery in here, that's for sure. And the power is generated through a process called induction. And in any NFC kind of pairing of NFC-enabled things, one of them at least must be what we call an active NFC device. In other words, it generates an NFC field. And when the other device, in this case a passive tag that has no power, comes into proximity with the device, induction will generate enough current through it for it to be able to function. And we can see that in action. I have an NFC field detector down here from one of our partners, one of whom is sat in the audience today. Hello, Bruno. Which has a little LED in the middle of it. And if I bring it into proximity with my device, you'll see that the light lights up. So if I place the device face down so I can approach the back of the device, which is where the antenna for NFC is, you'll see at some point, there we go, the light starts to flash. And I'm not actually touching the device. I'm a centimetre away from it now. So that's how the magic of tags actually works. Now, let's do a demo. Demos are always fun. And see what we can do with an application and NFC tags. So this is just a fun demo that John and I put together, and the idea was of either a kind of charity fun run or of the guy who likes to go jogging at lunchtime, and maybe this is me and he can't fiddle around with his stopwatch and everything before he goes out so he can time himself. So we put 2 tags by the front door, one marked start and one marked stop. And as I'm about to leave for my lunchtime run, I just tap or touch the first of those tags with my device, and it starts my handy stopwatch timer. And I now go running, not very far because I'm very unfit. And when I return, I touch the other tag, and the stopwatch stops as if by magic. But you know it's not magic because you're developers. Not that there's no such thing as magic. Come on now, we all saw Harry Potter. Now, very simple example. The essence of NFC tags is touch to make something happen, to trigger an action involving the data on the NFC tag itself. That's what it's all about. It's making things physically interactive, convenient and easy for the user. And users tend to really like working with NFC once they're familiar with it and they know it exists. So let's find out how we work with this in code. It's really, really easy, actually. Hands up, please, if you're aware of the invocation framework on BlackBerry 10. OK, for those that aren't, BlackBerry 10 includes an architectural component called the invocation framework. Kind of acts as a middleman between content and applications that can consume and process content. It's quite clever. This is what we use to inform the system that our application is interested in NFC tags that have a certain type of content on them. So you can see on the slide here, what I have is an XML fragment that appears in my bar descriptor file, my XML descriptor file for my application. I'm registering my application as a target for the invocation framework and saying that I'm able to open, in other words, consume, data of MIME type NFC.ndef, in other words, NFC tag data. And furthermore, I'm only interested in NFC tag data which is of the following type. And my property at the end there, the final entry in my descriptor fragment, says I'm interested in, I'll call it type 4 for the moment and then correct myself, and then a record type which has 2 parts to its ID. The rules are that for an external or custom record type, which is what I'm using here, I need to name that type in 2 parts, the first of which is a domain. So I invented my.rim.com. And the other part is just a string that you invent. So the 2 together comprise a unique identifier for your record type. 4 is actually called the TNF. That's the type name format. And the way NDEF works, several families of type values are recognized and defined. And the families, such as MIME, for example, that's one family, have a TNF number that indicates which of those families the type value relates to. So TNF4 means, hey, it's one I invented. Okay? So having included that in my bar descriptor file, I've declared that I can consume data of that type. So such data will be dispatched to my application. So the next question is, okay, so when that happens, how do I actually get hold of this data such that I can process it and respond in a suitable way, such as displaying my stopwatch? And the answer is in 2 parts, really. We have a class called Invoke Manager, which again is part of the invocation framework. And the Qt framework, or Qt if you prefer, has a really cool feature called signals and slots. And signals are like events, so objects can emit signals. And I, as an application developer, can connect signals emitted by particular objects, such as my Invoke Manager, to slots, which are basically methods that I write in my code. So when this object emits a signal which means, hey, I've got some data for you, it will result in a method that I wrote and named being called with some data passed in a parameter. So on the bottom half of the screen there, we have received invoke request. That's a method I named and invented. It's in my code, but I've connected it to the invoke signal that the invoke manager object will emit whenever it has some tag data for me. And you can see I get an invoke request object. It's kind of a wrapper class. And from there, I can extract its payload by calling request.data, and I get a Q-byte array. That's one of the Qt classes. And from there, I have some nice classes also from Qt, part of the Qt mobility subset, which lets me quickly and in one line of code parse that payload and turn it into NDEF messages and the constituent NDEF records that it contains. And then I've got my values, and I can go and do whatever I want to do based on the content, like either start or stop my stopwatch. So you don't need to write a lot of code to do stuff with NFC tags. It's very, very nice. Okay. John, actually, I do apologise. Let me just stop you there because
I hate this sort of ad-libbing.
Yeah, I'm sorry. You know how I do occasionally have brilliant ideas that are going to make me really rich?
Yeah.
I had a really brilliant idea that's going to make me really rich. Okay. And these guys, I think, have honest faces, and I'm going to share it with them. I'm going to take the risk that they're not going to steal my brilliant idea. Because I was thinking about NFC tags and how they can trigger actions and how cool that is. And I started to think, what about farmers? What if I was a farmer and I owned, say, 5,000 chickens, and they produce eggs, of course? What would the advantage be to me, as the farmer, if I was to affix NFC self-adhesive tags to the rear end of each one of my 5,000 chickens? How would that work? You don't need to imagine, because it so happens I have with me today a chicken. It was hard to get through customs, but it's here today. And this is a BlackBerry world exclusive, by the way, people. I'd like you to give a warm welcome, please, to the BlackBerry 10 NFC chicken. Oh. Thank you very much, people. Thank you, thank you. What was that? She's a bit nervous. She's never done a presentation before, but I guess not many chickens have. There she is, isn't she lovely? Now, oh, and what's this? She's got her own Twitter hashtag. Imagine how proud her mum and dad would be if you nice people were to send a message over Twitter with that hashtag. Only nice messages, mind. Her mum and dad are watching. So, we have my chickens, all 5,000 of them. They're NFC enabled. Let's see what the farmer's experience is now. What action will the farmer trigger? Oh, I nearly forgot something important because we have sound, people. Yes, we have sound. And not quite enough cable. Here we go. Eggs on demand. It's going to change the industry, I'm telling you. Okay, John, please bring these people back to... Thank you. Back to the real world. And talk about peer-to-peer
move that back. Thank you, Martin. I won't question you anymore about your agricultural preferences, but thank you. And basically, the message to take away from this is that using tags triggers events. So you can trigger things, you can make things happen. This has been a sort of amusing sort of lesson here, but that's the key message with respect to tags. Let's now talk about one of the other use cases that you've probably come across. Let's talk about peer-to-peer mode. It's one of the other standards areas that you'll find in the NFC forum. And the intention is that you can use it to transfer data between two NFC-capable devices. Why have NFC simply on one device and a tag? And using it to transfer data from one device by another. So you get to the use case which is surrounded by sharing information just by touching. Bring two devices close proximity to one another and share information. What kind of data could you share? It could be small amounts of data like contact information, URLs, text, telephone numbers, things like that. But it could also be larger amounts of data. I mean, I could, in principle, want to share maybe photos, image files, PNG files, music files, large bulk data as well. And you begin to think there that is NFC itself particularly good at handling large amounts of data like that? You can transfer it. But the use case of holding two devices close to one another for the period of time you want to transfer a large file it makes the use case a little bit... there must be easier ways to do that. So one of the standards that in NFC, in the NFC forum and peer-to-peer, is one around connection handover, where you can negotiate, you can use NFC to negotiate a Bluetooth connection. Say, in principle, the standards allow Wi-Fi as well, but we have a Bluetooth here. So for larger items, you could say, bring the devices together, let them negotiate a Bluetooth connection and transfer your file, because that means you could hold the devices much further apart than simply hold them together like this. The use case becomes a lot more compelling. So and it avoids the need to do the sort of usual pairing of Bluetooth devices. So let's have a demo. Let's have a demo here where we're actually going to share some files between a BlackBerry 10 device and another device, in fact a BlackBerry 7 device, to show the concept of interworking. So the idea there is that, let's go to the Elmo. So I have, let's see. So the application I have here, there's two devices. The one on the left-hand side is a BlackBerry 10 device. We're going to share a number of images from there. This application is populated with a number of images, including our Twitter faces and avatars, including some photographs as well, which my good friend Martin here has, as well as being an NFC guru, he's actually a very, very good photographer. So the use case here is I'm going to select a few files. I'm going to select these 3 files. I'm going to enable NFC sharing. And provided the gremlins don't get me, I'm going to tap the 2 devices together. There we go. Automatically pairing. And you can see now we're transferring to these files, and they can be separated. It's Bluetooth that is actually doing the heavy lifting of transferring the files. So what we've done here is allow NFC to negotiate a Bluetooth connection, which allows us to transfer bulk data files between devices. I can go in and possibly look and just to verify, in fact, that is that picture there that's been shared. So, let's switch back. So what we've actually seen there, let's just go here. So what we've actually seen there is the sharing of large bulk data files between two NFC-capable devices, where NFC negotiated the Bluetooth connection for you. How can you actually do some sharing from, let's say, from within QML? I think one of the principles around, that at least we've seen around developing applications, is try and do as much in QML as you can. And I think the topic of our next session in an hour's time relates to that as well. So in this, the basic principle there is, in this particular case, when you share an item, in fact, you use the invocation framework. I think Martin talked a little bit about that. You've got to identify a particular... What we're going to do here is actually send, in this particular case, it's a case of sending a vCard between two devices using NFC, using the invoke framework. You basically identify that you want to share some data. You identify the MIME type of the data that you want to share. There, it says basically NFC NDEF. We're sharing NDEF data. And then, down at the bottom, once the devices come together, you've actually got to construct effectively a byte array. You've got to construct the data that you want actually to send. In this particular case, we're constructing an NDEF message, which is, in this particular case, would be a vCard, presenting that to the data attribute of the invoke action item. And basically, that is how data gets transferred using over NFC using the invoke framework. This is another way you can use C++ as well to do this. this is, in fact, the code that actually implements the demo that we actually saw, transferring data over Bluetooth. We use something called NFC Share Manager. NFC Share Manager, you basically set it up. You provide it with a list of paths to files, like image files or audio files or whatever. So that appears in the QList URLs. You set up a request. You set a request telling you want to share files over the NFC Share Manager. You present the request to the NFC Share Manager, and it's as simple as that. The NFC Share Manager basically handles the negotiation of Bluetooth for you and transfers a list of files you presented as a list of URLs. So, that looked maybe complex to do. It was actually very simple with this, the NFC Share Manager class here. So let's continue our tour.
Thanks, John. Good stuff. I talk about NFC with friends probably far more than I should do. It's just a problem I have. But I would say of all the topics, probably peer-to-peer is the one that generates ideas and enthusiasm and all that kind of thing. And John and I are fortunate to work with some very creative people, actually, including some of the guys who work in our Swedish office in Malmo, one of whom was on stage today, Johan Larsby, during the keynote, and they're just full of ideas. And I was talking about NFC peer-to-peer mode with them, and a bit later on they sent me this email with a photograph which they said was a depiction of their vision of how NFC would revolutionise voice communications. I'm not sure if they were maybe pulling my leg. It looked like this. No, we all kind of walk around together, 1 centimetre from the friend we're talking to. I don't know. But I quite liked it, and it got me thinking about these things, which I confess I did in fact make when I was a small child. Not recently, to be honest. Who else made these things as a kid? Come on now, there we go. And I did wonder, could this old classic be updated with NFC? And it so happens. Ladies and gentlemen, another world exclusive.
I don't think you need that string, Martin.
You think it will work without the string?
I think it might just work without the string.
Just with NFC? That's an amazing. You see, he's the brains of the two. That's why he's here. So let's have a look at what we've got here and see what you guys think of this blatant frivolity. So here we go. Let's just clear that. So I'm going to type a message on the first one. Come on, keyboard, please. Demos. God damn it. Excuse me. Let's try that again. Oops, let's go there. Thank you. Hope you can see okay. Oh, that'll do. Right. Press enter, and what do we see? What we see is some Cascade animation magic, first of all, sending the message into the cannon along the string. And if I place the other device on top, and there's some... You can just hear the audio, good. Message received. So, we mock our Swedish friends, but they may be onto something. I don't know. It could well be the future. Now, moving on to more serious topics, because I have in fact been lulling you into a false sense of security here with the silliness. Because we're going to talk about a third aspect of NFC now called card emulation. And card emulation is quite hard. It's quite complicated, if I'm honest. There's a lot to learn. To become an expert in it, there's an awful lot to learn. There are 1 or 2 in this room, I think, actually. And I think they'll agree with me. So, card emulation, what is it? Clearly it's about emulating cards of some sort, but not those sorts. Okay? And before anyone suggests it, that's neither my girlfriend nor my wife, over on the far side there, much as she's very lovely. No. It's about smart cards. So, by show of hands, how many of you have worked with smart cards or have a good working knowledge of how these things work? A few of you, thank you, but most people not. And that doesn't surprise me. It's a really niche area. I only started getting involved with them maybe 3 years ago with the gentleman at the front here. He will remember. Smart cards are everywhere. Credit cards outside of the US usually are smart cards, and I'll talk about what they are in a moment, as is the ID card I used to get into the building at BlackBerry in the Slough area of England. So they're all over the place. To understand NFC's card emulation, therefore, we need to know a little bit about what a smart card is. So I'm going to do, effectively, a smart card 101 in like 3 minutes now. So pay attention to this bit. So what is a smart card? Number one, and I have to admit this blew my mind when I first started looking into them a few years ago, it's a computer. It's a small, self-contained, tamper-proof microprocessor. It has an operating system, it has a file system, and it has the ability to run application code. Those applications are typically called applets. Some people like to call them cardlets for some reason. When we encounter them in the real world, they're typically embedded in plastic cards of a standard size, certainly credit cards are. And they have various characteristics that make them secure. You can't install anything on them unless you've got the right encryption keys, and availability of those keys is managed through a highly secure manufacturing process. Where does NFC come into this? Well, these days, a credit card can have two interfaces. You can slide it into a slot at the shop when you're paying for some goods, and the metal contacts on the chip you can see embedded in the plastic there make electrical contact, and that's where the power comes from, and that's how communication takes place with the smart card. I'll talk more about that in a moment. Or it can have a contactless interface where we just touch or approach a reader, and just like tags, data will be transferred to and fro across that interface. Now, just like tags, smart cards don't do much on their own. They need a partner in crime, as it were, and the reader is that other part. And again, the reader provides power to the card, which is completely passive in other respects and can't do anything until it's powered, and the communication channel. So there is a kind of conversation takes place between the other side of the reader, next slide, and the content of the reader being specific applets. In other words, the application code that's crammed into this small, constrained computer. Look carefully at this picture, because the next slide kind of goes with it. General architecture is this. The smart card contains one or more of these applets. There'll be an application of some sort running on, let's say, a PC. Let's call that the external system, with the reader acting as the intermediary, allowing communication to take place between selected applets and that external system. And the external system always drives the conversation. It makes requests. The applets reply with responses. And this is all based upon a communications protocol called ISO 7816 Layer 4. So there's a spec. And there's a Layer 3 and a Layer 2 and a Layer 1, of course, because it's a stack. But to talk to a smart card, therefore, you need to understand that protocol and be able to formulate application protocol data units, send them, receive and understand the response you get back from the applets on the card. So that's a generic smart card architecture. Watch what happens when I press this button. Because, hey, this is what NFC's card emulation is all about. We substitute the plastic physical smart card for a software-based emulation of exactly the same set of capabilities. And as you can see from the slide, we have a thing called a secure element, which itself is almost like an embedded smart card. It's a secure, tamper-proof, self-contained environment capable of running applet code. And I'm talking about the same code. We're not porting it to BlackBerry 10. This is not application code. It's the same applet code will run inside the secure element, plus any associated cryptographic stuff that's required to support its operation. Now, your BlackBerry 10 smartphone may have up to 2 secure elements available for use in some form. The device itself has one embedded in it, that we made as part of our product. But also, very commonly these days, SIM cards, or UICCs as they're often known in telecom circles, also contain secure elements and therefore can host applets in them. Not shown on the slide there, though, sitting underneath the applets are applications, the kind of things that you and I will write. And one of the advantages of emulating smart cards in this way is that I can emulate multiple smart cards within the same hosting kind of environment that my smartphone and its secure elements provide, not just one. And I can select between emulated cards using an application called a wallet. But I also have a user interface. And real applications, the sort we'd write in Cascades, for example, can be used to make life easier, convenient, and informative for the user. Plastic smart cards don't have a UI, typically. Okay? And last but not least, card issuers can manage and issue and provision in a secure way their emulated smart card components, those applets, over the air. So it's very powerful. Now, for users of card emulation solutions, life isn't that different to using a physical contactless smart card. Instead of approaching a reader, like a point-of-sale reader in a shop, and touching your card to it to pay for some goods, you use your smartphone, which doesn't even need to have a battery in it necessarily, because power for the secure elements can be induced in the same way as for tags. Fantastic. There's a box there I'll draw your attention to. It says detect an NFC transaction. The other thing that applications can do to make life better for users is that they can have a relationship with particular applets in the secure elements, whereby the applets can tell the application that they did something. Hey, I processed a payment transaction. And the application then can then, of course, advise the user that this took place, or it was rejected, or whatever. Let's look at some code. If you're going to work with card emulation, number one, someone on the team needs to know about smart card applets. We're not covering that today. It's quite a specialist topic and not really a BlackBerry topic, to be honest. But as an application developer, you will be concerned with being able to talk to those applets for various reasons from your application code and respond to events triggered by applets when they do things like process a payment or authorize access to the train station because it's a valid emulated ticket. And you'll use C APIs. We have a thing called the BlackBerry Platform Services, which you may have heard of, collection of C APIs. Quite powerful, actually, an awful lot you can do in there. And you'll do things like this. You'll open a logical channel to the secure element, and you'll name a specific applet, which is the one you want to talk to. Applets have an ID. It's a long hex number called an AID. So you'll name that AID and establish a connection or a channel to it that you can communicate over. And you'll do things like transmit APDUs and receive the responses and progress a transaction through that exchange of APDUs with particular applets. Again, details beyond the scope of this session, I'm afraid. To receive notification from a particular applet that something's happened, we use the invocation framework. Similar to what we saw for NFC tags, we register something in our bar descriptor.xml file, and here you can see I'm saying I'm interested in NFC_transaction data, and specifically transactions raised by the applet whose ID is 6E.6E.66. and so on. And that's all I need to do, and I'll get a callback to my code via the invoke manager, same kind of stuff, and I can respond to it. Really easy for developers to do that side of things. Last word before I hand over to John for the next chapter in the story, if it were. NFC payments, probably the thing you read the most about in the press. Possibly the thing that will touch most people's lives as it starts to take off, and there are signs are that it will. It is quite complicated, not just from a technical point of view, though. You need a few specialists in the team because of the specialist smart card aspects of it. What you really need above all are the right business relationships, because there are lots of parties involved. There are banks, there are card issuers, there may be other organisations if it's a non-payment kind of solution that you're working with. There's an organisation who has the role of TSM, that's Trusted Services Manager, concerned with personalising and provisioning these emulated cards in a secure way. And the carrier will be involved in payments for sure, and probably we will too. There's lots of different parties, and it takes some setting up. So I'll close here by simply saying that if you have a card emulation solution in mind, some ambition in that area, John and I will look to facilitate conversations with the right people. So come and see us afterwards, send us a message on Twitter or whatever, and we'll try and hook you up with the right people. So, on that note, I'll hand back to John, and John's going to talk now about virtual target emulation in our last 15 minutes.
Right. Thank you, Martin. I think one of the take-home messages from Martin's section there has been that if you do card emulation, you must have a relationship with someone who owns the real estate inside the UICC, the secure element. These can live in a SIM, and therefore the relationship must be with the mobile network operator. Or if it's an embedded secure element in a device, say a handset, then you must have a relationship with the vendor of the owner of the real estate and the secure element. You can still do card emulation in this context by doing virtual card emulation. So what is virtual card emulation? It's card emulation where the application doesn't live inside a SIM, a secure element in a SIM or an embedded secure element on the device. So if you had remembered the diagram from the previous section, you would have remembered that the top part had the applets living in the secure element, and they provided a lot of the business logic to provide the transaction handling and processing. With virtual card emulation, in this case, the application that handles the business logic is an ordinary BlackBerry 10 application, right? Now, if you have a secure element, then you get a lot for free. You get the secure storage and that. You get a lot of the benefits of having an applet running in a secure element. Therefore, if you're doing it yourself in a BlackBerry 10 application, you have to do a little bit more. There's some onus on you as a developer of this application to develop a little bit more to accommodate these things. But for many applications, like sort of loyalty payments, loyalties and things like that, doing it this way is actually a very good way because you're decoupled from the mobile network operator or the owner of the secure element. So, in essence, the virtual target emulation, basically your BlackBerry 10 device becomes effectively like an NFC target or card. As far as the reader or the application that's driving the application, it can't distinguish the two. It uses the same protocols. The reader, in effect, in the application can't distinguish them. There are some things that you can't do. I mean, if you're using real physical tags, there are certain attributes of tags that are set in the factory when the tag gets manufactured. For example, the UID, unique identifier, maybe one of those. And obviously, you're not able to emulate arbitrary UIDs from within an application doing virtual target emulation. How do you do it? Well, it's actually very similar to everything else that we've talked about here, in particular in card emulation. This particular set of sequences here shows doing virtual emulation of effectively building an NDEF message here and then serving it out through virtual target emulation. Simply, you create the message, so the first three statements really build up an NDEF message out of a record and content and payload, and you simply ask the NFC services on BlackBerry 10 to start emulation with that particular NDEF message. It's as simple as that, not very difficult. So, reading contactless cards.
Thanks, John. So this is the last of the 5. Increasingly, cards such as, and I did have my wallet's in my bag. I was going to show you my credit card and carefully hide the number, but my credit card now has a contactless interface, and that could offer some possibilities, perhaps, if I was able to read a contactless card from a BlackBerry application, and it so happens I can, and that's precisely what this part of the session is about. For payment cards aside, things like this, which I'm holding up in such a way that most of you can't see it, so let me press this button. That's a ticket for the public transport system here in Amsterdam. It's a contactless ticket. It has a contactless interface. You tap in and tap out as you use the bus or the train. So, if we had the ability, which we do, to read contactless cards in a certain way, there are some possibilities for making life easier for our users. We could do things like extract data from contactless cards to save the user having to key it in. Maybe there's a payment screen they have to key in their credit card number, well, what if they could just touch it? The physical card to the back of the device, and it magically appears in the fields of the payment form. That's possible. Similarly, what if I just want to keep track of how much I've used of this thing? Okay, what balance is left on it, or what my most recent transactions were. The possibility is there for an application to allow the user to touch the ticket to their smartphone and your application display useful information to the user. It's about convenience again. So there's a kind of visualization of a fake payment scenario. That's not a real credit card, of course, in the middle photograph. But you can see that the first screen shows some payment details required, a card number and an expiry date. And it's certainly technically feasible to retrieve that data from a real credit card. It so happens that credit cards all conform, most of them conform to a standard known as EMV. And some of the data, if you choose to go and read the many specifications on the subject, I'm not saying it's easy, is in clear. Okay? And you can obtain some of that data and utilize it in a useful, sensible way in your own applications. So exactly how you do this kind of magic, extract data from cards, there isn't kind of one way, because it very much depends on what the card is. It depends on the layer of the protocol stack that it exposes, what the highest layer supported is, how you're going to talk to it, and it depends on what data is on the card, how it's stored, where it's stored, and whether it's encrypted or not. So lots of ifs and buts there, and you need to know the card, the specific card, very, very well to understand what the possibilities are. You're going to need to work perhaps with the issuer, obtain specifications such as for credit cards and so on. So it's not a one-size-fits-all magic solution. You need to know the card. So in essence, this is what you do, though. The card will be brought into proximity with the device. The BlackBerry 10 application is now acting in the role as the reader, and it will have a conversation with the card. It will send application protocol data units, APDUs, of some appropriate type that the card understands. The card will respond, and the response will contain the data you're looking for if you've sent the right commands. So again, you need to know what commands to send. That requires you to know your card quite well. And the example here shows, once again, us sending ISO 7816 Layer 4 smart card APDUs, because I'm dealing with a Type 4 NFC tag. Those support that interface, whereas Types 1, 2, and 3 do not. And users will be delighted at not having to key things in, or actually knowing they've used their transport ticket twice or something. So code looks like this, and once again, we're using the BlackBerry Platform Services C APIs. It's quite straightforward. You kind of run in an event loop, but we start off by calling this method NFC register tag reader writer. And in brackets, we have to indicate the layer of the protocol stack that our target card supports. More details on that outside of this session, but layer 4 is commonly the one that we'll use. Once we've done that, then at some point we'll be notified by an event coming into our event loop that the card has come into proximity, and we can exchange APDUs using the NFC tag transceive method. So we'll send it an APDU and we'll get a response back in our structure we've reserved some memory for. So not a lot of code involved, but you need to know the card. So we'll finish this section on with a demo. I told you before, I have, actually from the last time John and I were here a year ago, John is a hoarder of NFC things, and he very cleverly thought to retain the travel pass we were issued with a year ago, and we can read it. So what I have here running on the device is an application called NFC Tool. John will kind of close with some pointers to resources, but in GitHub we've got lots of code actually, one of which is an application called NFC Tool. This is a later version we haven't released yet, but will soon, and it includes, it's kind of a toolkit of lots of different NFC functions, so you can see how to do them. And we've added, for the purposes of today, this Amsterdam Transport Pass demo. It just gives an event log, and it shows us what's happening and what data we can see on the ticket here. So I'll just bring it into proximity. It's quite difficult for you guys to read, I fear. Can I zoom in, I wonder? Can I operate the technology up here? I can. Look at that. So critically, we can see that there's only been one transaction, which was when it was originally purchased. We don't live in Amsterdam, we haven't used it, but sure, there are two. I think the two most recent transactions are available in clear on this card, so you can extract them and display them, and it's quite easy to do in the case of this particular card. Okay.
Thank you.
Thank you. Over to you, John.
So I think that basically brings to a close our main use cases. And what I hope you've learned is that there is a breadth to NFC that just doesn't include things like payments, which is maybe one that's been most visible. It's very interactive technology to place in your application, a very powerful technique to embed that capability. The applications that you've seen, the demos, you get a chance to write those yourself tomorrow. We're running a hands-on lab where we're going to be doing 2 sessions there, two examples, triggering NFC actions by reading tags and some peer-to-peer stuff. So if you want to get hands-on and have your own NFC chicken, come tomorrow.
There's only one NFC chicken.
There is only one NFC chicken. In terms of resources that are available, Martin, we publish a lot of articles on the web. There's a tiny URL which relates to that. All the code that we do, we write for these demos, will find its way onto the Cascades Community Samples in GitHub. Go there, use that as a resource. Use that as a resource for a starting point for any of your NFC-related applications. We've covered all of the use cases in there. And we have follow us on Twitter, because that's a very good way of allowing us to answer your questions. Martin and I tend to do EMEA and some APAC type stuff. Our friend at the back, Rob, is more North America. And he covers those. Stand up, Rob.
No
Stand up, Rob. Stand up, Rob. There you go.
There he is.
There he is. He's nailed now. So follow us on Twitter, because it's a way of us helping. Don't forget, you can download your conference guide there. Complete session surveys. It's very important to get feedback on the sessions. And come round tonight to the European Appreciation event in the foyer in the RAI ground floor. Thank you very much. I hope you've enjoyed it.
Thank you. So, I think we're unfortunately quite short of time. We appear to have about 3 minutes, but we'll be told to stop when the time comes.
2 minutes, I think.
If you have any questions, we'd be glad to try and answer them now, but we're around for 2 days, so if anyone wants to chat, please come and find us. Yes, sir, you at the front.
You showed earlier...
There's a microphone coming here.
Yeah. Hey, so you showed earlier that you can register in your bar descriptor your intent to receive a certain type of NFC
We did.
resource.
Yeah.
What happens when multiple applications in the system are waiting for the same kind of information?
Shall I?
Yes, if you want. Go ahead.
Yeah. In the case where we have registered a very unique custom type for our application specifically, it's highly unlikely that another application would have used the same value, and that's the purpose of the domain component of that, to avoid kind of namespace clashes, really. But where well-known types like text or a URI are concerned, the expectation is that there will be one or more applications that could handle a URI or some text. So there's a user experience aspect to this. The way a BlackBerry 10 device will respond when the invocation framework finds that, hang on, there's more than one application that has registered for text or URI, is it will pop up a dialog that lists those candidate target applications for the user to choose from. And the user can make their choice, and if they want to, at the same time say, hey, and this is the default, use this one from now on for NDEF data of this type. So probably a one-off choice they have to make, and after that, their favorite application, like the browser, will handle that type of code. Data. Thank you.
Oh, Rob wants to add something.
This sounds like a heckle.
Stand up.
Is this a heckle?
Come and heckle us. I think this will be the last thing we have to do before we...
I'd just like to say that if one of the applications which is a target is in the foreground, there's no choice. It goes to that.
Yeah.
Thank you, Rob.
Correct. I think we're pretty...
We have a red light.
We have a red light here, so I think we're pretty close to winding up.
Yeah. Thanks very much for coming along anyway.
And
we'll see you around. Have a good event.
Yeah, and next session we're doing is in half an hour's time.
Half an hour's time somewhere else.
We're doing a deep dive now.
106, I think.
Thank you.